I wanted to share some two proportion Z test examples with you. So we're going to take a look. Again, we'll follow the same process that we have for all of the other hypothesis tests that we previously learned. Step one, you state your hypothesis. Step two, you identify the information you need. Then you use Minitab to calculate your test statistic and p-value. You make your decision and write your final conclusion. So we begin by reading the example. So this one says, Time magazine reported the result of a telephone poll of 800 Americans. The question posed of the Americans who were surveyed was, should the federal tax on cigarettes be raised to pay for health care reform? And the results of the survey were, non-smokers, there were 605 and 351 said yes, federal taxes should be raised to pay for health care reform. Smokers, there were 195 surveyed and 41 of them said yes, the federal tax on cigarettes should be raised to pay for health care reform. So the question posed is there sufficient evidence at the 0.05 level to say or to conclude that the two populations, smokers and non-smokers, differ significantly with respect to their opinions? Now here again, you got to think about, okay, proportions. How do I know this is a proportion? It doesn't outright say it, but it has your groups divided into smokers and non-smokers. So that's one clue that we're doing a two proportion test, or it could be a two mean test, is that you have two groups and you want to compare the groups. And the two groups come from the same population. You have them divided by some particular characteristic. This one is smokers and non-smokers. The second thing is that I notice is they tell me how many were in each group and how many responded positively to the question. So from there, I could calculate a percentage or a proportion. So that's kind of my clue that I'm going to do a two proportion test. And again, two proportion because I have two distinct groups and I want to compare. The question says, do they differ significantly? Okay, so again, the first thing we have to think about is stating our hypotheses. So, as always, you still have a null hypothesis and you're going to have an alternative hypothesis. The null hypothesis will always, again, in some way contain equal, and the alternative is the exact opposite. The hypothesis should be given somewhere in the scenario, and this one is kind of this last statement, the question, can we conclude that the two populations, we're looking at the big picture, differ significantly with respect to their opinions? Okay, so I have to think about this and think about what the word differ implies in terms of mathematics. Well, differ means not the same. So in my mind, that implies not equal. And not equal would go in the alternative hypothesis. So we're trying to say, and again, you have two groups and you need to understand which group is which. Well, notice how they have this set up. They have N1 and Y1 for the non-smokers. So group 1 is going to be the non-smokers and group 2 is going to be the smokers. And guys, it matters because if you put them in Minitab in reverse, you get the wrong answer. Okay, so we're going to compare the proportion of group 1, which is your non-smokers, to the proportion of group 2, which is your smokers, and we're saying that they differ, which means they're not the same. So the proportion for the non-smokers does not equal the proportions for smokers. The null is going to be the exact opposite, and we know that the exact opposite of not equal would be that they are equal. I kind of like using NS and S because then it helps me to keep straight which one is the first group, which one is the second group. But there's our hypothesis. We're saying that proportion for non-smokers equals proportion for smokers. That's the null. The alternative is that the proportion for non-smokers does not equal the proportion of smokers. And they've really already given us our information in table form here, but if you wanted to rewrite it down, you could, but you have this table where the data is already summarized. So I don't see the need to rewrite it, but then I've got to go out to Minitab and put all this information into Minitab. So let's go out to Minitab to calculate our test statistic. We're going to go to Stat, Basic Statistics. This time we're doing 2 proportions, and we have summarized data. So sample 1 in our case is the non-smokers. So if I look at the non-smokers, we have 351 who said yes out of 605. So 351 out of 605. For sample 2, which is our smokers, we had 41 out of 195. So 41 out of 195. And I'm going to options. We're using a 5% or 0.05 level of significance, so the confidence level is 95. We're saying there is no difference, so that's 0. We're using not equal, and we want to estimate the proportions separately. I click OK. I click OK again. Again, Minitab calculates the values for us and gives us our p-value and our test statistic. Okay, so from this we find that our Z test statistic, which we should record, our Z test statistic is 10.45 with a corresponding p-value of 0. You're going to read the normal approximation. Okay, you're going to read the normal approximation. Okay, so then we have to make our decision. We're going to compare the p-value to the level of significance. So my p-value is 0. My level of significance is 0.05. Again, if you make that comparison digit for digit, first digit is 0, so there's no difference. Second digit for P is 0. For alpha, it is 5. 0 is less than or equal to 5, so the p-value is less than or equal to alpha. When P is less than or equal to alpha, we reject the null. So again, thinking about what that means, if we reject the null, that means the null is false and the alternative is true. Okay, so our alternative says that they are not the same or they are not equal. So again, thinking about how to state your conclusion. Again, you should always include the level of significance. So we would say at the 0.05 level of significance, the two populations, smokers and non-smokers, differ significantly in their opinion or opinions as to whether the federal tax should be raised on cigarettes to pay for health care reform. It does differ because we said that the alternative was true. Okay. All right, let's look at the second one. A university financial aid officer samples undergraduate students to determine whether male or female students are more likely to get a summer job. Of the 802 male students sampled, 725 got a job in the summer, and 573 of 717 female students sampled got a job. The officer performs a two proportion test to determine whether male or female students are more likely to get a job in the summer. Use a 0.05 level of significance. Now, a couple of issues that you may think about as you're looking at this problem is it doesn't really tell us whether males should be group 1 or whether females should be group 1. The rule of thumb typically is whichever is mentioned first becomes group 1, whichever is mentioned second becomes group 2. So if as I'm reading this, I notice that they give me the information about male first. So I'm going to make that group 1, and it gives me information about the female second. So I'm going to make it group 2. And it can benefit you to actually write that down just like I did. Okay. He says whether male or female. So we're comparing male to female, and the statement he's making, they are more likely to get a job in the summer. So it's kind of like he's going to say in making this comparison that males are more likely to get a job in the summer than females. Okay. So again, you're having to kind of read between the lines. Okay. He's trying he's saying that males, again, because we're going to say group 1, males are more likely to get a job in summer than females. Guys, you have to kind of read between the lines because it's logical and it's common sense if you'll take your time and pay attention. So the first thing I need to do is, as always, state my hypotheses. So I have to think about for a minute, what does it mean are more likely? Well, to me, that kind of seems to imply that it's greater, that more males are going to get a job in the summer than females. So this is greater than, so that's going to make it the alternative. So we're saying the proportion of group 1, which are the males, are more likely to get a job than group 2, which is the females. So that's my alternative. Therefore, the opposite of that, which is my null, is that the proportion of males is less than or equal to the proportion of the second group, which is females. Now, since this information was given to us in sentence form, it's the last sentence of the first paragraph, it may help us to actually kind of create ourselves a little table of this information so we make sure we get it entered correctly. So if I make a table, I'm going to have male, which is group 1. I'm going to have female, which is group 2. And we have to think about the sample size and how many basically said yes, I had a summer job. So it tells us that 802 male students, so I had a total of 802, and that 725 got a job. And then it says 712 females were surveyed and 573 got a job. It also tells us to use a 0.05 level of significance. Okay, so I've got to go and put all this information in Minitab. Again, we go to Stat, Basic Statistics, two proportions. We're comparing males to females. We have summarized data. Sample 1 is our males. We had 725 out of 802. For the females, which is sample 2, we had 573 out of 712. We are using a 95% confidence. Hypothesized difference is 0, but this time we want it to be greater than, and we're going to do the proportions separately. We click OK twice, and Minitab goes to work, and we get our information. Okay. Whoops, got it in the wrong place. Let me undo that and get in the right place. Okay, so if we look at the results from Minitab, again reading the normal approximation, we find that our z-test statistic is 5.47 and the p-value is 0. We then compare the p-value to alpha. So we're going to compare 0 to 0.05. Again, comparing digit for digit. First digit after the decimal in both cases is 0. Second digit for the p-value is 0. For alpha is 5. 0 is less than or equal to 5. So the p-value is less than or equal to alpha. When p is less than or equal to alpha, we reject the null. So if we reject the null, that means the null is false and the alternative is true. So based on the evidence that we have at this particular time for this particular sample of students, males are more likely to get a job in the summer than females. Okay, so we would write our conclusion. At the 0.05 level of significance, males are more likely to get a job in the summer than females. Now again, that's based on the evidence that we have. If we go out and collect a different sample, we could come to a different conclusion. But you have to base your conclusion on the evidence that you have on hand at that particular moment. So that gives you two examples of a two-port proportion Z test.